about Cartesian divers and how they're similar to ballast tanks in a submarine. Table 2.
Hi.
Can you give your bottle a squeeze and let's see what happens to that little dropper when you squeeze it. Oh, it dives, doesn't it? And then it ascends. Can you guys tell me what makes that dropper dive? Why does it?
The water pressure. The water pressure.
Okay, so when you squeeze it,
It sucks in water.
does more water go into the dropper when you squeeze it?
Yes.
And when more water goes into that dropper, does that increase its density?
Yes, it gets heavier.
Yes, it gets heavier. Yes, the density increases and it dives. Now, Jaden, can you tell me why does it go back up? What makes the dropper go back up?
All the water gets back into the bottom and it loses water pressure.
Okay, so I'm looking at this little dropper and I see at the top of the dropper, there's a little bubble. Does that air bubble, does that force the water out when you stop squeezing it?
Yes.
It does, doesn't it? Let's look at this table here, and I've got another bottle, and it looks like you guys are getting it to dive. Good. Can you guys tell me what makes the dropper dive?
The water density in the dropper.
Okay, the water density changes. So when you squeeze it, some of the water in the bottle, where does that water go?
It goes inside the dropper.
Oh, it goes inside of
Because it has nowhere else to go when you squeeze the bottom.
and then it dies. So when you stop squeezing it and it goes back up to the surface, what makes it ascend?
The air pressure.
Oh, there's a little bubble in there, isn't there? There's a little tiny bubble. And that bubble pushes some of the water out and it decreases the density inside the dropper, doesn't it?
Yes.
Oh, that's cool. Okay, just like a submarine's ballast tanks. Let's come over here. And I've got another bottle here and I'm with table 6. Can you make it dive?
Yeah.
Down it goes. And the submariner says topside. And back up it goes. Can you guys tell me what makes it dive? Why does it dive?
Because the water density. Wait.
Because of water density. Tell me more.
And the water density makes it go down.
Yeah.
Okay, so is there more water when it dives or less water in the dropper when it dives? More water. So when I squeeze it, I'm forcing water into the dropper. And when I stop squeezing it, does it have less density or more density when it ascends? Less density. Way to go. Great answers. Okay, and I'm over here. Let's look at your diver, table 4. Can you make it dive, Brooklyn? Down it goes. And then the submariner says, take her topside. And up it goes. Can you guys tell me, why would that dropper sink like that?
Because the water in the bottle gets in it.
Yeah, the water inside the pop bottle is forced into the dropper when you squeeze it, and the dropper becomes more dense, and it sinks. Now, when I stop squeezing it, what forces the water back out of the dropper?
The water comes out.
What's in that dropper? There's a little tiny, yes, there's a little bubble of air in there, and when I stop squeezing it, the air bubble forces the water out, and it goes topside. Good job.